The amount of rainfall in January in a certain city is normally distributed with a mean of 4.9 inches and a standard deviation of 0.6 inches. Find the value of the quartile Q3. Okay, so we see that the word normally distributed is here. That's perfect. And the random variable that we are trying to find out is the amount of rainfall in January. And it's basically saying that the x is normally distributed with the mean value as 4.9 and sigma as, or the standard deviation as 0.6. Now, what is the third quartile? Well, that's when you have the 75% or the 3/4, 3/4, that's why it's Q3, 3/4 from the bottom. So if you look at the bell curve, what you're looking at is you want to know this value Q3, where this much is like 75%, okay? This is the value we want to find. However, it's easier to find the value where the z-score is gives you 0.75, and because this allows you to use the standard normal distribution. Okay, so we're first going to find this solution and somehow work from here to find the Q3. Okay, so how do you get that? Well, you will probably notice that this is somewhat different from our previous questions where you usually are given this value and you're trying to find the probability. Here you're given the probability and you're asking for this value, and that's called the inverse norm. All right, so that's something that you have to be careful. Although this says normally distributed, so it's nice, you just have to know how to use normally distributed thingy. But wait, that's not all, because if you actually write down what it means, you're asking for the value which gives you the given probability. So that's the challenge here. So in that case, because it's asking the opposite of the probability, it's called the inverse norm. And we will need to, let's see. Okay, so I'm going to use this calculator. And we are going to go to second vars and take the inverse norm. And when you do this, don't touch the mu 0 and sigma 1. That just means we're using the standard normal distribution. So don't do anything, just put area as 0.75 for 75%, okay? Now, some calculators also ask you for left, center, and right. You just want to choose the left, okay? So normally we'll always use the left one, and then think about how to translate in other cases, okay? So we enter, and that gives you 0.6745. And using that value, let's see what that means. So the inverse norm, when we did the 0.7501, we got 0.6745. And because this is the z-score, in the formula z-score equals to x minus mu over sigma, the corresponding Q3 for the original x has to be solved from this z-score formula. So we write this down and first multiply sigma both sides, which will give you the sigma times 0.6745 equals to Q3 minus mu. I'm switching left and right. Hopefully that's not going to confuse you. All I did was I just moved the sigma here, okay, and then switched left and right. So that's what we have, and then furthermore you add mu both sides, and therefore you get this formula. Q3 is mu plus this 0.6745, we call this the critical value. So mu plus the critical z-score times sigma, and then you calculate this with the given value 4.9 and 0.6 plugged in, and you get 5.30. So that is the critical point where the third quartile is.